Hey everyone, and welcome to The Explainer. Today, we're going to talk about Podman. You've probably heard of it. It's this modern, secure, daemonless container engine that's really shaking things up as a serious alternative to Docker. So let's just jump right in with a question that, honestly, a lot of us in development and operations have been asking. We all know containers are essential now, right? They've totally changed the game for building and shipping software. But have we been running them in the safest way possible?
And look, you gotta give credit where it's due. Docker made containers a household name. It made them easy and accessible for everyone. But its architecture, which is built around this one central daemon, came with a few, let's call them challenges. This single process, often running as the all-powerful root user, created a potential single point of failure, and, more importantly, a pretty big security headache.
And that right there, that brings us to the absolute core issue that Podman was built from the ground up to solve, this whole daemon problem. Okay, so take a look at this. It really breaks down the difference perfectly. On the left, you've got the Docker model. Every single command you type has to go talk to this middleman, the Docker daemon, which then goes and manages your containers. But look at the right, that's Podman. It's so much more direct. Your command just starts the container. It's a direct child process. No middleman, no central service running with root privileges. All right, so how does Podman actually pull this off? Let's get into the specifics of this really elegant, daemonless solution to what is a pretty fundamental architectural problem. So what is Podman? Well, the name itself is a hint. It stands for Pod Manager. At its heart, it's an open-source engine for running OCI-compliant containers. That OCI part just means they stick to the Open Container Initiative standard, so they're portable. But the key phrase here, the most important part, is without a central daemon. It's designed for a world that prioritizes security and tight integration with modern Linux systems. It really all comes down to these three big ideas. First, being daemonless, which we've talked about. Second, and this is a huge security win, it runs containers as a regular user or rootless by default. And third, it's pod-native design, which, as we'll see, makes it the perfect partner in a Kubernetes world.
Okay, let's get under the hood a little and see how this architecture really works in practice. And let's introduce Podman's secret weapon, something that really sets it apart.
And this quote, it just hits the nail on the head. This is the security implication right here. Since there's no daemon, every container just runs with the permissions of whoever started it, you. There isn't some background process hanging around with God mode privileges, which just massively shrinks the potential attack surface. And this is that secret weapon I mentioned. Podman natively understands the idea of pods, a concept that comes straight from Kubernetes. So what's a pod? It's just a group of containers that are designed to work together, sharing resources like a network. This lets them talk to each other super easily.
Now, this is incredibly powerful for local development. Look at this workflow. You create an empty pod. Then, you launch your web server container inside that pod. Then, you launch your database container inside that same pod. And just like that, they can talk to each other over localhost exactly like they would in a real Kubernetes cluster. You're basically mimicking a production setup right on your own laptop.
So, okay, we've talked about all these cool features, daemonless, rootless, pods, but what does this all mean in the real world? Let's talk about the tangible benefits, especially when it comes to security and how it integrates with your system.
Let's just let that number sink in for a second. 0. That's how many root daemons Podman needs to run. By being rootless by default, it just completely wipes out an entire category of privilege escalation attacks. I mean, think about it. If a container gets compromised, it can't take over the whole machine if it never had root access in the first place. It's that simple. And this table just lays it all out, side by side. It's so clear. Is it daemonless? Yep, Podman is. Is it rootless by default? You bet. It's not some experimental feature. Does it get pods? Absolutely. And as we're about to see, its integration with systemd, the core service manager in Linux, is just top-notch. Now, this is a total game changer for anyone running containers on a Linux server. With one simple command, Podman could spit out a systemd service file for your container. What does that mean? It means you can now manage your container, start it, stop it, have it automatically boot up with the server, just like any other normal system service. It is so clean and so robust.
All right, enough theory. Let's see what this all looks like in practice. How does this actually fit into your day-to-day workflow as a developer or a sysadmin? You're probably thinking, okay, the switch is going to be painful, right? Well, check this out.
For most people, the transition is almost ridiculously easy. Because Podman was designed to be a drop-in replacement, it speaks the exact same language. You can literally run this one-line command to create an alias, and poof, a huge chunk of your existing scripts and muscle memory will just work. And here is where it all clicks together. This is the bridge. After you've built and tested your multi-container app locally inside a pod, you run this one command, podman generate kube. Podman looks at your running setup and automatically writes out a Kubernetes-ready YAML manifest file for you. You can then take that exact file and hand it off to your production cluster. It's a perfect, seamless path from your laptop to the cloud.
Now, it's also really important to get that Podman isn't trying to be this one giant monolithic tool that does everything. Nope, it's part of a modular family of tools, really following that classic Unix philosophy of doing one thing and doing it well. Podman's job is to run containers. When you need to build them, there's a tool called Builda. When you need to share and move images around, there's Scopio. Each tool is a specialist, which gives you a ton of flexibility and security.
So let's just recap. Why should you care about Podman? Well, it boils down to 4 huge things. It's fundamentally more secure, thanks to being rootless. It's way more integrated with the operating system through systemd. It's more composable, letting you use the best tool for the job. And it's truly Kubernetes native, making it just about the perfect sidekick for modern cloud development. And all this really leaves us with a big question to think about. As we move forward, what do we want from our tools? Do we want a single, all-in-one application that tries to do everything? Or do we want a set of focused, secure, and composable tools designed to work together perfectly? I think Podman and its ecosystem are making a very, very strong case for that second option.